Let's look at some applications involving bearings. And in navigation and surveying, the term bearing is used to describe the location of one point relative to another. So when we look at point O and point P, we want to describe the relationship that P is to O. It's helpful to have a north-south line drawn and an east-west line drawn. But the angle that the line segment OP makes with the north-south line is 40 degrees. So when we're drawing bearings, the first letter represents either north or south. The angle in between is always, it has to be 90 degrees or less. And then the second letter is either east or west. And so since we rotated to the right, towards the east from the north, this is going to be north 40 degrees east. This next example, we have a north-south line. Our OP line segment is 65 degrees, makes a 65-degree angle with the north-south line. But this time we've rotated towards, the angle is towards the west, so it is north 65 degrees west. Now in the third example, if I drew this picture again, and suppose we've got a 70-degree angle from the south, and so the acute angle that OP makes with the vertical axis is 70 degrees. And so since it is a 70-degree angle with the south, it's going to be south 70 degrees east. Now the question is, if I drew the angle from the north here, that would be, I know the angle in here, the little angle would be 20 degrees, and then the first quadrant is 90 degrees. So the other way to draw that OP would be saying that this is 110 degrees. And so the question is, why don't we say north 110 degrees east to describe OP? And the reason is that we always use an angle that's 90 degrees or less. And so 110 is over 90. Instead of going from the north, we're going to go from the south. So with bearings, we always start with the north or south. If the acute angle is made from the north, then we'll start with an N. If the acute angle is made from the south, we'll start with an S. And then the direction of the angle, it will either be east or west. And remember, that angle has to be 90 degrees or less. Instead of doing these problems with you right now, why don't you give it a try? Find the bearing from O to B, A, C, and D. Pause the video and then turn the video back on. And just remember, you always start with north-south, and your angle has to be acute. And for some of these problems, the angle given may not be the one that you use. You may have to subtract to find the correct angle. All right, in this case, where we used to find reference angles, we counted the angle from the line segment to the x-axis. But for bearings, we're actually using the angle that you make with the y-axis. All right, let's start with the first one, the bearing from O to B. Here's O, here's B. I have a 40-degree angle made with the north portion of the vertical axis, so it's going to be north 40 degrees, and since our angle, we rotated to the west, we are to the left of the north. We're going to have north 40 degrees west. The bearing from O to A, be careful not to use the 20 degrees because that is made with the horizontal axis. If that angle is 20 degrees, we know that the little angle in here has to be 70 degrees. So from O to A, we're going to be north 70 degrees east because we are to the right of the vertical axis. Right? From the bearing from O to C, so we've got O to C, we have a 75-degree angle. Again, that's with the horizontal axis. We don't want that. We need our acute angle to be made with the vertical axis. So if that's 75 degrees, this little angle in here has to be 90 minus 75, or 15 degrees. So OC is going to be south 15 degrees west. And the last one, from O to D, we do have an angle that is made with the vertical axis, so it's going to be south 25 degrees east. All right, let's look at an example using a bearing. It says a boat leaves the entrance to a harbor and travels 150 miles on a bearing of north 64 east. How many miles north and how many miles east from the harbor has the boat reached? Round your answers to the nearest mile. So I'm going to start by just drawing a point. That's the harbor. And I'm going to draw a vertical line, just a broken vertical line, to show my north and south. So this would be north and this would be south. And it says north 64 east. That means that my angle is going to be made with a line segment that would be to the right of the north. The angle is going to be 64 degrees, and you don't have to draw it perfectly, just as long as you label it correctly. This angle right here is 64 degrees. We've gone to the right of the north, so this is where the boat is now. The question is, how many miles north and how many miles east from the harbor has the boat reached? And so if I want to know how many miles north, I want this distance right here. We could call that y. And if I want to know how many miles east, we'll talk about this distance right here. We can call that x. So if I just want to draw that triangle to help me see it a little bit better. I know that I've gone 150 miles, so that distance right here is 150. We said this was 64 degrees. This is a right angle. I want to find y and I want to find x. So we're going to use the trigonometric function since this is a right triangle. So to find y, I have adjacent and I have the hypotenuse. So I know that the cosine of 64 degrees equals y over 150. Y equals 150 times the cosine of 64. 150 cosine 64. It says to round to the nearest mile, so y is approximately 66 miles. And if I want to find x, I know that for x, I have the side opposite my angle and the hypotenuse, so I'm going to have the sine. So I know that the sine of 64 degrees is equal to x over 150. So x equals 150 times the sine of 64 degrees. We'll evaluate that in our calculator. 150 times the sine of 64 degrees. So x is approximately equal to 135 miles. The boat would be 135 miles east of the harbor and 66 miles north. And one way to check your answer would be to, use the Pythagorean theorem. We've got 135 here, we've got 66 here, and we can just double check. 66 squared plus 135 squared, and then 150 squared. And we do get some error here because we've rounded to the nearest whole numbers. So again, we're looking to see if our answer is reasonable, and that is reasonable.